Hello students, myself Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. Okay. See, in this chapter, Instruction Set and Assembly Programming of 8051, we are learning the different instruction sets. Understood? So, in the previous sessions, we have learned the immediate the addressing modes. So first you have to learn the addressing modes if you want to how to use the instruction set. In the addressing modes, we have learned different types of addressing modes like immediate addressing modes, register addressing mode, direct addressing mode, indirect addressing mode, and index addressing modes. After that, we have learned the different types of instructions like data transfer instructions. Data transfer, how to transfer data from one register to another register. Okay, how to move data to the register. For that we have used the move instruction. And then next we have learned the arithmetic instructions. In the arithmetic instructions we have learned how to use the add instructions, subtraction instructions, okay, multiplication, division, and if you want to increment the register or decrement the data, how to use the instructions. Then after that we have learned the logical instructions. In the logical, how to use the and, or, okay, not, etc. Then we have seen the rotate instructions. If you want to rotate right or if you want to rotate left, how we are going to use the instructions. Then after that, we have seen the exchange instructions. If you want to exchange the data or if you want to move the data from source to destination, and how you are going to use the, or what you are going to use the in the 8051. Understood. And in the last class, we have seen the branch instruction, that is your jump instructions. In the jump instructions, as in the last session I have explained, we will be having two types of jumps. One is conditional jump and the other one is unconditional jump instructions. Then we have seen the what are the ranges that are present in the 8051. We were having three ranges: relative range, that is from minus 127 to minus 128 to plus 127. Then we have absolute range. Absolute range is from 0000H to 07FFH. Then long range, that is from 0 to 64K, that is 0000H to FFFH. These are the three different ranges that are present in the 8051. Then we have seen the unconditional jump instructions. What is unconditional jump instruction? In the unconditional, it will jump to the specific address without any condition. Will not be having any condition. Then we have seen the three instructions, that is A jump, L jump and S jump instructions. Okay. So in today's session, I am going to give a lecture on conditional jump instructions. What are conditional jump instructions? Okay. So generally, the conditional jump instructions, it will be of 2-byte instructions and these are of short jump, that is your S jump. It will be in the range from minus 128 to plus 127. So this conditional jump instructions are all of short jump instructions. Understood? And in the conditional jump instruction, first of all, what is conditional jump instruction? In the conditional jump, it will change its program flow only when a condition and a certain condition exists. Okay. So we will see the different conditional jump instructions now one by one. So if you see the table here, we are having JZ, that is jump if accumulator is 0. Then JNZ, jump, you have to jump if accumulator not equal to 0. One more thing you have to remember is in JZ and JNZ, the register we are using is only accumulator. Other than A, we cannot use the other register. Okay, remember that. Then DJNZ, that is decrement and jump if accumulator is not equal to 0. Next CJNE A comma byte, jump if accumulator is not equal to the byte. CJNE register comma immediate data. Jump if byte is not equal to hash data. JC, jump if carry is equal to 1. JNC is jump if carry not equal to, carry is equal to 0. JB, jump if bit equals to 1. Next, JNB, jump if bit equals to 0. Next is JBC, jump if bit is equal to 1 and clear bit. These are all the different conditional jump instructions. Now we will study one by one. Okay. Now first one is JNC. What is JNC? Jump if carry not set. If carry not set, that means your carry should be 0. It has to jump only when carry is equal to 0. Else it has to continue with the program. So what is the syntax of the JNC? JNC relative address. So we have to give here JNC next, JNC label 1, label 2, like that we have to mention where it has to jump. Next, see here, this instruction, it will only jump if carry is equal to 0. Otherwise, if carry is 1 means, then what it will do? It will just continue with the flow of the program. It will not jump anywhere. Understood? See, let us consider an example. Okay, here we have taken some instruction sequence here. Let us assume that our carry flag is set. That means our CY is equal to 1. Now we will see the instruction sequence. JNC label 1, CPL C, JNC label 2. Now what it does here? Here we have assumed our carry flag is 1. So JNC jump if carry not set. CY is 0, then only you have to jump. So here since CY is 1, so what it has to do? It has to just go with the flow of the program. It will not jump anywhere. It will not jump to label 1. It will just continue with the program, that is complement C. Then JNC label 2. If here it is carry flag is 0 means, then it will jump to the address of the label 2. Understood? So it will clear the carry and cause program execution to continue at the instruction identified by the label 2. Understood? And as I already told you, the conditional jump instructions, they all are of 2-byte instructions. Understood? See, when we do the programs, then you will understood. As of now, you just know what does this instruction will do. Understood? So JNC means have to jump only if carry is equal to 0. Understood? Next, JC. What is JC? JC is jump if carry is set. That means you have to jump only if your carry CY is equal to 1. Else you have to continue with your program. Okay. So what is the syntax of this? JC, relative address. This relative address, it can be anything. Just like as I told you, some labels, any labels you can give here. This is a user one, anything you can give. So if the carry flag is set, branch to the address indicated. Otherwise, continue with your next instruction. Let us consider an example. So in this, we will assume that our CY is 0. Carry flag is 0. Understood? So JC label 1. So when it has to jump, in case of JC, it has to jump only if CY is equal to 1. But here we have assumed CY is equal to 0. That is why it will continue with the next instruction. That is after JC label 1, then it will go with the CPL C. Then JC label 2. If here it is CY is equal to 1, then it will jump to the label 2. Else it will continue with the flow of the program. Okay. Next, JNB. Jump if bit not set. That means you have to jump only if whichever the bit you are using, that should be 0. Sorry, if it is not set, if it is not 0, then you have to jump. So syntax JNB bit address comma relative address. If the indicated bit is 0, if whichever the bit you are giving there, if it is 0, then you have to jump. Else you have to provide with the next instruction. Let us consider an example. The data present at the input port 1. See, port 1 we are having this data and our accumulator is having 56H. If we see the example here, JNB P1.3 label 1. So JNB means what? Jump if bit not set. If it is 0, then only you have to jump. But here it is your third P1.3 means that is, this is your third bit. That is from here, if you consider it 0, 1, 2, 3. If it is 1, see here it is 1. That is why it will not jump. It will continue with the next instruction. Then it will go JNB accumulator 3 label 2. ACC 3 means again it will check the third bit in the accumulator. If you see here, third bit is 0. If it is 0, then what it will do? If the indicated bit is 0, then it will jump to the label 2. Understood? So here we are checking JNB is for a particular bit. Understood? Next, JB, jump if bit set. Here, if a bit is equal to 1, then you need to jump. Else you have to continue with the next instruction. That is JB bit address, comma, relative address. If we consider an example, JB P1.2, comma, label 1. In the port 1, the second bit that is equal to 0. When you are using the JB, you have to jump only the particular bit is 1. But this is 0. That is why it will come to the next instruction. It will not jump to the label 1. When it comes here, accumulator dot 2, comma label 2. So what is the second bit of the accumulator? Here it is 1. If it is 1, then it has to jump to the address of the label 2. Okay. But here this JB and JNB it is of 3 byte instruction. First one is your opcode and next two are your address, target address. Next is JNZ. JNZ means jump if accumulator not equal to 0. The syntax is JNZ relative address. So in this instruction what happens? If any bit of the accumulator is a 1, then jump to the indicated address. Otherwise, it will continue with the next instruction. In this example, let us consider our accumulator will be having 0, 0. JNZ label. That means jump if accumulator not equal to 0. See, since but it is 0, it will not jump. It will continue with the next instruction, that is your increment A. Understood? So here increment A, that means initially your accumulator was 0, 0. When we use the instruction INC, your accumulator will be incremented to 1. So now we are having here A is equal to 1. Next, JNZ label 2. Jump if accumulator is not 0. Here your accumulator is not 0. It is of 1. So it will jump to the address of the label 2. Understood? So this is also of 2 byte instruction. Next one is your JZ. JZ means jump you have if accumulator is 0. If your accumulator is 0, then you have to jump. Else you have to continue with the next instruction. Syntax is JZ relative address. Sorry, this should be JZ. Okay. If all bits of the accumulator are 0, jump to the address indicated. Otherwise, proceed with the next instruction. If we consider an example, move A, R0. So in your accumulator, you'll be having the value of the R0, JZ over. If in the accumulator, if it is 0, if accumulator is 0, then you have to jump to the over. That is, over is somewhere here. So to this address, your this one PC has to come here. Okay. Then move A, R1. If it is 1, 1 means then it will continue with the instructions. Understood? Remember one thing, for JNZ and for JZ, you have to use the accumulator. Other registers you cannot use. Next one is DJNZ. DJNZ means D means decrement and jump if not 0. Okay. The syntax is DJNZ register, relative address. Let us consider an example. See here, this program, it will adds value 3 to the accumulator 10 times. See, move A, hash 0. That means initially you are clearing your accumulator, your A will be having 0. Now you are loading your register R0 from 2 10. Then add A, hash 03. That means your accumulator is added with 03. Okay, DJNZ R2, again. In the R2 you are having the value of 10. So decrement and jump if not 0. So here R2 is 10. If you decrement, it will become 9. It is not equal to 0. So if it is not equal to 0, then again it has to jump to again. Again means it will come here. So this will repeat 10 times until your this one will become R2 will become 0. Once R2 is 0, then it will continue with the move R5, A. DJNZ means decrement and jump. First you have to decrement, then check if it is equal to 0 or not. The next instruction is CJNE. CJNE means compare and jump if not equal. Okay, first you have to compare, then if they are not equal, then you have to jump. The syntax of CJNE is CJNE operand 1, operand 2, relative address. So it compares the magnitudes of these two operands and then it will jump if their values are not equal. Let us consider an example. Accumulator is having 34H and our register R7 is having 56H. Okay. So now the instruction is CJNE R7, hash 60H, not equal. It will compare R7 and 60H. Okay. So in our R7 we are having 56H. 56 and H 60H. It is not equal. If it is not equal, then it will jump to the address of this label. That is, it will come here. Then JC. This is some other label. If it is equal, it will not jump. It will continue with the next instruction. In the CJNE, these are the different representations. That is CJNE A, direct, relative address. That is, you will compare the direct byte and the accumulator and jump if it is not equal. And here you are comparing your accumulator and the immediate data. And here you are comparing the data that is in the register with the immediate data. Then this is the CJNE for indirect data. That is, we will compare with the hash data. If it is not equal, it will jump. So these are the different conditional jump instructions. See, all these conditional jump instructions, these are all short jump instructions. It will be having the short jump. Understood? It is your JC, JNC, JB, JNB, DJNZ, CJNE. Understood? For JZ and JNZ, you have to use the accumulator only. Remember this. See, when you write the programs, then you will come to know how we are using these instructions. So when you are studying only the instruction set, as of now, you understood what this instruction does. Okay, what is the syntax and what is the function of this? Now first you learn this. When you are solving the or when you are writing the programs, then you will understand how to use this. Okay. Now let us solve some MCQs based on this. First one. All conditional jumps are absolute jumps, long jumps, short jumps, none. Number of times I have mentioned all conditional jumps are short jumps. It will be in the range from minus 128 to plus 127. Next, DJNZ R0, label is dash byte instruction. DJNZ R0. DJNZ means what? It is decrement and then jump if it is not equal to 0. It is of 2-byte instruction. JZ, JNZ instructions checked content of dash register. Which content registers it will check? Is it DPTR, B, A or PSW? This also I have mentioned. It will check the content of the accumulator register, that is your A register. The mnemonic used to perform a subtraction of source with an 8-bit data and jumps to specified relative address. If subtraction is non-zero, then which is the instruction? It is DJNZ, CJNE, JZ, JNC. So read the question once again. The mnemonic used to perform subtraction of source with the 8-bit data and jumps to specified relative address if it is non-zero. That is your CJNE. Compare the operands. If it is not equal, then you have to jump. Understood? The mnemonic JNB is used to jump to the specified relative address only if the specified bit is 1, specified bit is 0, specified bit is non-recursive and none. It is specified bit is equal to 1. Now, match the following instruction mnemonics with their description. CJNE A, direct, relative address. CJNE A, hash data, relative equal. Relative address. CJNE at RI, hash data, relative address. CJNE RN, hash data, relative address. See, you have to match the following. See, first one, compare immediate data to indirect and jump if not equal. See, for first one, CJNE, direct, relative, compare your direct byte with accumulator and jump if not equal. Understood? So, the answer is B here. Okay. The descriptive questions they ask you explain the conditional jump instructions of 8051 or separately also they can ask you explain the JB JNB instruction with syntax and an example. Always when you are explaining the instruction set, remember you have to write the syntax and then you have to explain the syntax with an example. Syntax as well as example both carries the equal marks. Understood? I hope you understood today's session. Thank you for listening.